Okay, so today we're going to talk about even and odd functions and how to determine whether they are an even or odd function or neither. Okay, so in this here, odd functions and even functions, or let's talk about even functions. So a function f is an even function if this is true. If we plug in f of negative x and we get f of x back out. So if we replace x with negative of x and we get the same function back, then if that's true for all x in the domain, then it's an even function. In other words, if it's symmetric with respect to the y-axis. So if the graph of a function is symmetric with respect to the y-axis, then it is an even function. If a function f is an odd function, if this is true, that if I replace f of x with f of negative x, right, and I get the opposite of f of x, then, and if that holds true for all x in the domain, then it's an odd function. Or in other words, if it's symmetric with respect to the, oops, not y, nope. Yep, that's wrong. It should be the origin. Oops. I knew that didn't look right. There we go. So so in other words, what we can do is we can look at the symmetry. If a equation is symmetric with respect to the origin, if its graph is symmetric with respect to the origin, then it's an odd function, which means this holds true for all x in the domain. If a given equation has a graph that's symmetric with respect to the y-axis, in other words, this holds true, then we call that an even function. And those are the definitions. So now next time I'm going to do examples of where you would use this to prove whether a function is even or odd. Okay? Thanks.